if
I don't think is the lesson recording.
yes, yes, it is. So if A is odd, then either A or B is odd. So the negation for this one is gonna say if A and B is odd, then A and B is even. So which means that's a negation. If A squared plus B is odd, then A then A and or change to and B is even. So that's a negation of this statement, that statement. This is the first one. And then the second one is write down the converse of A. So the converse of A so the converse of A, this is number B. Let me just read it. So it's gonna say if A squared plus B is even, then A or B is even. Then C, let's write down the contra positive of A. So the contra positive of A, it will be let me check. Do you have the memo for this question paper?
No, I don't.
Oh, okay. So the contrapositive of that statement, it will be if either not at neither A and B is odd, then A plus B, A squared plus B is not odd. So that's the counterpositive of A. So in this one here, for the first one, there is something that if A squared is odd, then A and B, I wrote D there. It's supposed to say B. A and B is, so in this one here, for negation, then A and B is, they are going to be, we have to say they are, A and B are odd. They have to be. The only thing that changes is or. The A and B are odd. The only thing that it need to change is this and or there. The other thing is fine. So this one is fine. And then also this one is fine. So the other one here, especially in B, I write if A and B is odd, then A or B is even. So the other one you might find the other student writing it in this way, which is still the same. If either A or B is odd, then A squared plus B, A squared plus B is not odd. So it's the same thing. It can say it's not. A squared plus B is not odd. So when we say it's not odd, obviously speaking, which means it's going to be an even. So that's how this is number B. You can even write it in this way or that way. They are the same. So let's move to question number.
I think I found the memo. I don't think this is right.
Okay, what is the memo saying?
I'm sending you it.
Okay, because we answered from 1A, B, C, ne? Okay, let me open it.
Oh no, wait. I think the answer I sent you is wrong. This is a different question.
Uh, Here it says if A squared is odd, then either. Let's check the question. I think it's the same question.
Uh, no, it's not.
It's not. Yes, yes, yes. Because this one it says if A squared is odd, then either A or B is odd. Not both. But the question is the same. You see that? No, 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 no. This one it says A plus B squared. You see that?
Yeah, I saw that.
Yeah, but the point, even if it's A squared plus B squared, it does not really affect. So let's see, let's check, write down the negation of A. They say if A plus B squared is odd, then both A and B are even. So let's check to our answer. If we check in our answer, if A squared plus B is odd, then A and B are what? Are odd. Ne? So in this one here, they say then both A and B are odd. If A squared is odd, then no, this one is not a memo. Is somebody's work. Someone, it's not the memo for this question paper. Because that person there, if A and B are odd, then that person made a mistake there. But it's fine. Let me just verify, but it's someone's memo. It's not the university memo.
No, I think it's from the university. I'm not sure.
Oh, okay. Let me just verify quickly, because the only okay, yeah, the first one here, yeah, this is where I'm the one who made a mistake there. This one, it have to be even, not odd. Both are even. It's right there. And then for the second one, let me check the answer there. It says if either A or B is odd, then A plus B is odd. Ne? If either A or B, then A or B is odd, then A squared plus B is okay, yes. And then for number 2, this one here is odd. I'm not supposed, it's not odd. Both of them here, it have to say odd there. It's odd. And then number three, let me check number 3, number C. Write down the contrapositive of A. So for contrapositive, if both A are and B, if neither A or B and B is odd, then A squared plus B is not odd. So in here, they say if both A and B are even, then A plus B squared is even. So this statement, if you read what you sent me there and this one, is the same thing. You see, if in that one is if both A or and B are even. So if I said if neither A or B, neither B is odd, then A squared plus B is not odd. So which means it's even. So even there, you will see at the end that then A plus B squared is even. So not odd, it means that is even. So this one is also correct. It's just that the way we wrote them is different. Like we use different words, but it's the same. It means the same thing. Do you get it?
Yes, I understand.
Okay. So number D, for number D, it says, let me check the way. Remember, you guys, when you answer the questions, the way you are going to answer your question, it won't be the same as the other student. So, which means the person who's going to be marking your script, you will be knowing that like this is either like you can write it this way and this way. So, out of 400 or 500 students, because there are many students there, they are not going to answer the same. That's why when they check for plagiarism, if you guys you write exactly the same, they know that you guys you were helping each other. That's how they found out about the plagiarism. So is the converse of A true? Give reasons. So number D. So the converse of A actually is not necessarily true. So the reason part when I'm saying it's not necessarily true is because of the original statement for A squared plus B, A squared plus B is odd, then either A or B is odd, not both. So not both. Then which means, let me just write it down, not by number D. I will say it's not true, not true. The reason part is that the statement, that statement which state that a squared plus b then either a or b then this means a squared plus b is odd. So this is not always the case. So this is not always the case. So if I can give you example, a counter positive example, I'm going to be using a number. If I can say let a equals to 2 and b equals to 3, whereby 2 you will see that is even and b is 3. Both are not odd, ne? B is 3. We're gonna make it 3, which is odd. So if we substitute there in this a squared plus b, you will see that we're going to have 2 the power 2 plus 3, which is equals to 7. So which is odd. So in this case, if you check, one of the value or variable that we use there is odd, the other one is even. But the results is what? But the results are odd. Therefore, the results are odd. Therefore, the converse of A, the converse of A is not true. So why are we saying the converse of A is not true? We are saying the converse of A is not true because of if you check the converse of A, it was question number B. If either A or B is even, then A plus B is odd. Ne? So if we check this one, it says if either A or B is odd, then A plus B squared is odd. Then so in this one here, according to the way I've read that statement there, I will say this one is I will conclude that the converse is true, is true, because the reason part is that when I'm reading that converse, if a squared, whenever we put it's either even and odd, the results are always going to be odd. So then this converse we can conclude that the converse is true. The converse of A is true because the results always give us what? They always give us odd number. So the second one, then this one says let S equal to A1, A2, A3, AN be a set of test scores, prove using the method of contradiction that if the average of this set of test scores is smaller than 75, then at least one of the score is less than 75. So we have to prove by contradiction. So when we do that, okay, let me just write it. Just give me 1 minute. So this is question number. So what is we're going to do there? We're going to say, so we are going to assume so in our assumption, we're going to say we're going to assume that all the scores so all the scores in the set S, we're going to assume that they are greater than or equal to 75. So when we assume that, then we're going to let our N be the number of scores in the set S. And we're going to let also A1 and A2 be the test score. It will be the test score. So now, which means every number there that we have written, we have A1 is going to be greater equals to 75. A2 is going to be greater equals to 75. And so on until AN, which is going to be greater equal to 75. Then the average is going to say AV. I will just use AV. So the average is going to be saying A1 plus A2 plus AN over N. So which means since A1 plus A2, we know that A1 plus A2 plus until AN must be great equal to 75 multiplied by N, 75N. Then the average AV will be greater than, our AV will be greater than 75. So when our AV is greater, it's going to be greater than 75. So it will contradict. This is going to contradict our assumption. It's going to contradict. It's going to contradict our assumption that the average of the test score is smaller than 75. Therefore, since this leads us to contradiction, then the statement, the original statement, is true. Then the original statement is the one which they give us in the question paper. So this is how you prove it. That's how you do it when you are proving that question. Unless otherwise, if you can check in your memo there if it's the same.
The memo they use 80 instead of 75.
They used 18. Okay,
80.
80. Oh, okay. Maybe it's because of the question paper is not the same. Ne? But here in this question paper that we are using 75, you see. So you might find that in the one that you are having there, because they just look similar, maybe you might find that they use 8. But the steps must be, all the steps must be the same. So in this one number, we can proceed to number 1.3. So 1.3 says, give the function f r to r, real to real, defined by g of x is a piecewise function 2x plus 1 if x is greater than 0, in x. If x is less than 0, find whether or not g is injective or surjective. Find the inverse of g if it exists. So here we are going to introduce x1 and x2. So when we introduce x1 and x2, we are going to check if we plug g in the function of f where g is that. If we plug g of x1 and then also g of, is it going to be equal to g of x2? Are we going to get the same thing? So at the end, we must get x1. The first thing, we must get x1 to be equals to x2 at the end. And we must also check about the 1-to-1. If this function is 1-to-1, then that's when we're gonna know that is surjective. So the first thing that you need to know in this question is that you must know if a function is surjective. What is the meaning of surjective and what is the meaning of injective? Surjective and injective and bijective. So bijective, it must have both. The function must be as surjective and injective. You must prove, when you prove it, you prove for 1-to-1 and also the x1 if it's going to be equal to x2. So let's just go straight to it. So to check injective, we're going to check 1-to-1. If the function is 1-to-1, a function is, so I'm gonna first give you the definition of injective so that you know it. When we talk about injective, a function is injective if every distinct element in the domain has a distinct image in the codomain. In other words, no two different elements in the domain can map to the same element in the codomain. So that means that if I have 1, 2, 3, and A, B, and C, if one map to A, the two map to B, like that. So there is no one which must be mapping. You find that is also mapping to A. 2 is mapping to A, then it won't be injective. So let's check if that function is exactly what we thinking is 1-to-1. So we have in G of x, we have 2x plus 1 for e is greater than 0 and ln x for x is less than 1. So for case, we're going to start with case. For case x is greater than 1, greater equal to 1, we have g of, you can use a and b, or you can use x1 and x2. The answer will still the same. So g of a must be equal to g of b. Then if g of a must be equals to g of e, for this a and b must be greater equals to 1, because our x there is greater than 1. Then this means that 2a plus 1 is going to be 2b plus 1. Then if we solve this, you will find that our a equals to b, because this one is going to subtract there. You will be left with 2a equals to 2b. Then our a is going to be equals to b. So when we have solved that our a is equal to b, we're going to go to case 2. This was case 1. Our case 2 is x is less than 1. So for case 2, when x is less than 1, we do the same. G of a must be equals to g of b for a and b is less than 1. Then this means that we were having ln there. So if we say ln A is going to be equals to ln B. So if we have ln A equals to ln B, then if we introduce in both here, we can introduce E. Like, let me just write it, ln E equals to e to the power ln B. Then you will see ln e to the power ln, it gives us A is going to be equals to B. So when we get that, we show that A equals to B. Therefore, we have shown that, therefore, this function, therefore, g of x is injective. It's 1-to-1, it's injective. So let's go and do another one again to check surjective. When we check surjective, we are checking onto. Onto is, when we talk about surjective, we are talking about onto. So when we talk about onto, a function is surjective if every element in the domain has at least one pre-image in the domain. In other words, the function covers the entire codomain. So what exactly do we mean about that? So when you, I'm just gonna go straight to proving if this function is surjective. So here, if we let, for example, if we let y be any element, be any element in R, we need to find an X such that we're gonna need to find an X such that G of X is equals to Y. So in the first case, here we are dealing with case because it's a piecewise function. Case 1, when your Y is greater than or equal to 1, then we have this function there. Remember, when Y equals to 1, for Y is greater than 1, then we can find X equal to you know how I get this one? Remember our function there, it says 2x plus 1 equal to 1. Then if I take this 1, the other side is going to say 2x equals to y minus 1. It's like we are getting an inverse, in other words. Then we divide by 2, then our x is going to be y minus 1 over 2. So that's how I get that y there, x there, that function. Therefore, now we're gonna say we have our g of x, which is equal to 2x plus 1, can be written as equal to 2. Where there is x, we're going to use y minus 1 over 2, whereby this, you will see it will cancel with that. And we have plus 1 there, plus 1, which if this cancel with this, we're going to end up having what? Y. Ne? So g of x covers all. So g of x, it covers all, y covers all. Y is greater than 1. So we are done. We got that g of x is equals to 1. Then we go to case 2. Should I erase here?
Yes.
Oh, okay. So we're gonna go to case 2. Case 2, we are going to check when y is less than 1. So when y is less than 1, we have, remember we have ln x. We have ln x there. So equals to y. So which means if I put e, I will have x equals to e to the power y. So when I have x equals to e to the power y, then our g of x, which is equal to ln x, which equal to ln x, is going to be equals to ln of e to the power y, which is going to be equal to y. So g of x, it covers all. Therefore, now we can say g of x, since based on case 1 and case 2, g of x is what is also is surjective. Surjective. Then let's check. The question says we must check if the inverse. It says we must check the inverse. So inverse of g if it exists, to check if it exists. So let's check if the inverse of G exists. So to check if that case the inverse exists, we're going to have we have y equals to 2x plus 1. And then you know that this one we're going to write it as x equals to y minus 1 over 2. And another side also, this is for case 1, when x is great equal to 1. And we also have y equals to ln x. And this is e equals to x equals to e to the power y. Then g -1 of x, this means for inverse, is going to be y minus 1 over 2 if x is greater than or equal to 1, and it's going to be e to the power y. If x is less than 1. So that's how it is. This is, we have answered the question, that question complete. So how is it your memo saying?
The memo is different.
It's different. How did they, can I see how they answered it? How did they?
The question is slightly different.
Oh, it's not the same. Oh, okay. No, I understand. So, but that's exactly the way I did. That's how you answer for surjective and bijective. So, surjective and injective. So now I'm gonna extend in this question. If they want you to answer to check if the function is bijective, it must be both injective and bijective, surjective. So if the function is injective and surjective, so like this function that we were just working out now, then it means that this function is bijective. So I'm just saying that so that next time if you can get a question, you must answer it. You must remember how to answer it.
Can you look at the memo?
I don't have the memo for this unless otherwise if.
I sent you it, the
Oh, okay.
PDF.
Oh, okay, okay. We were doing question number
1.3.
okay, 1.3. Okay, yes, yes. So 1.3. Oh yeah, it's this one. This one is different because of, do you see that it's when x is greater than or equals to 2, but the questions are the same there. So the numbering, the way they're going to do it, for case 1, you see that for case 1, we did exactly the same thing. If you rewatch the video, you will see that 2x minus, I was using a and b. I told you that you can also use x1 and x2. Then they got that x1 equals to x2, and then they were trying to check for injective. Then they also got that exactly what we did there. Then if it does g is injective, we did exactly the same. For the case 2 again, there I see all right, both there, the way they are doing it here, they are trying to use the limit. Okay, they found that is infinity, g of x, okay, and g of 1 again. Then what they did there, let me just follow them, but it's more confusing. Okay, so in this one here, the problem part in our case, we were dealing with x is less than 1. So this is less than 2. So that's why when the subject, so the question won't be exactly the same as the other step won't be the same as ours. So this one, that's why it says there is no inverse. It's because that this question is not really similar to the one that we just did now. So that's why, but the way we did it is perfect, is fine. Just that they are not really similar, but we did the right work there. So any question?
No questions.
All right. Yeah, we did, like when you answer, just answer exactly the way I was doing when you answer this kind of question. So let's check the other one. So this one, I know you are good with it, the one we are going to do now, because we have been doing this kind of questions. It's question number 2. It says, consider the sequence an equals to 4n squared minus 3n over that. Show from the first principle that this sequence converges. So do you remember how to do it?
I'll have to go over it again.
Okay. So when we show from the first principle that this sequence converges, you must remember that you use the limit. So the only thing that you need to do, you will just say, let me just write it here, because you can say limit when n approaches infinity of an equal to limit when n approaches infinity of 4n squared minus 3n over 2n squared, 2n squared plus 4. So when you done that, when you have done that, you can say, because of the n there, we have n squared, you can divide everything by n squared. Then you will have limit when n approaches infinity of, when we divide by n, we're going to have 4 minus 3 over n divided by 2 plus 4 over n squared. So remember that limit, always you must remember that when n approaches infinity of 1 over n equals to 0, then which means here now the answer will be 4 over 2, which is equal to 2. So since we got the value that is 2, then it means that, so since we got that, we got the 2, it means that this limit converges because it approaches what? It approaches 2. So now if we proceed with this question, you will see that if we say, okay, you can say the absolute value of 4, that question, it was 4. This one is when you are writing what you are. Remember, like when you say f of x minus L, it will approaches what? It's less than epsilon, less than delta, or you can say epsilon less than delta whenever absolute value of n of f of x minus L is less than epsilon. So this is the definition that we're going to use there. So in that definition there, we gonna say, okay, let me just write it. I didn't memorize that. Okay, it's 4n squared minus 3n over 2n squared plus 4. Then we're going to say absolute value of 4n squared minus 3n over 2n squared minus, is it minus 4? Plus 4. Plus 4 minus L, our L we got that is 2. It's going to be equal to, then you multiply by this, it's going to be 4n squared minus 3n minus 4n squared minus 4 minus 8 over 2n squared plus 4, which this is going to give us, this will cancel with this one, then we're going to be left with minus 3n minus 8 over 2n squared plus 4. Then when we're left with that, you will see that if so if we have this one plus 4 there, we will have to find something. So let me check. I just want to check something quickly. 3 divided by taking out there is gonna be 3n minus 8, which is 2. So if we check some estimation, you will see that this one here, the absolute value of 3n minus 8 is going to be less than or equal to absolute value of negative 3n minus 8n. We introduce n there. Then this is going to be equal to, if we check here, going to be absolute value of minus 8 minus 3 is minus 11n, which is equals to 11. We can just say 11n. And if you check also, we can also do the one for 2n squared. For absolute value of 2n squared plus 4 is gonna be also equal to 2n squared plus 4n squared, which this is going to be the same as 6n squared, which this one here for 6n squared is going to be the same. We can just say 6n squared. So now absolute value of negative 3n minus 8 over 2n squared plus 4 is going to be less equal to, we write it's going to be 11n over 6 n squared. So it's going to be less than 11n over 6n squared, which this we can say is 11 over 6n. 11 over 6n. Then we let our e, we can let e greater than 0 be given. Then when we let e greater than 0 be given, Therefore, there exists an integer n. There exists an integer n, which is an element of natural number, and with this n is going to be greater than 11. So sorry, it's going to be greater than 6. 6 over 11. 6 over 11e. So now this is according to the postulate, Archimedes postulate. So now we have n, which is greater than n. So this is going to imply that our n, which is greater than 11, 6 over 11 e. So this is going to imply that in this 611e, we're going to have 6 over 11 n, which is less than epsilon. And this will imply that absolute value of 4n squared minus 3n over 2n squared plus 4 minus 2 is less than epsilon. Then my answer will end there. You end here. Then this is the end of this question. So any question?
Where did epsilon come from?
Or epsilon, this e. Yeah, we are working based on the definition. Let me erase that. Remember, when you do this function, it says absolute value of f of x minus L must be less than f of x minus f of must be less than a delta whenever f of x minus L must be less than epsilon. So there is something that I think here is not f of x, is not L here. Is f of here is f of x minus, here is not f of x, sorry. Here is going to be x minus a. X minus, in our case there, x minus a must be less than delta whenever f of x is less than epsilon. So we have to prove that. Why we were proving that in that equation we're going to get epsilon. So in this equation, when we write it, it's like our x minus the limit. When we calculate the limit there, we got that when we say limit, when n is like x approaches a. So in us here, it was n approaches infinity. So n approaches infinity of is less than delta whenever absolute value of f of x. I'll just write f of x, which is 4n squared minus 3n over 2n squared plus 4 minus, we got that is 2, which is less than epsilon. So that is why we were trying to prove that exactly this is going to be epsilon. So when we say given, when we say let e greater than 0 be given, then we were finding a delta in such a way that, which, because here we are working with number, with is a real analysis, is not calculus. We found an integer n. So in this integer n, we have to make, that's why we got that this integer n is going to be equal to 11 over 6n. So in this one here, we make it to be less than e, so that we can know what is e. So when we make it less than e, then you will find that our E, if we multiply there, we got that is 6 over 11E. So that's how that E come from. So the E there, we are using a definition. So if you check in your book, you will find the definition of this. They have the definition. Do you get it now?
Yes.
Yes, it's just a matter of we are using a definition. We are just trying to follow the structure. So I thought maybe we're gonna do 2 hours today. Then I think we can have only 1 hour. Then the other one we're gonna take it starting from Monday.
Okay.
Yeah, but on Monday also we have a class. So I'm not sure which module do you think? I think we can finish this question paper because I mean like we're gonna continue with this question paper because we did question 1, then we can do question 2, question 3 and 4 on Monday. Tomorrow I won't be teaching. Then we're gonna see where we're gonna get there. So I think we can end this and this class today now. Then I will see you on Monday.
Can you give homework?
Oh, okay, no problem. The only question that I can give it to you,
Just one question.
yes. I want to give you this kind of question because I want to see, especially for question 5, question 2. So let me check one of the questions in question 2. For question 2, it's a nice question because it's always there. And let me check. Oh, 2019. Yeah, you can do question 2.1 and 2.2. You can take a picture or screenshot. Screenshot, yeah. Are you done?
I took a screenshot.
Okay, yes, you can do it and you send it to me. It's exactly the same. Maybe also, if you will have time. Yeah,
Just
if
go
you have
through that question. I have 2 assignments.
Oh, okay, yeah, question 1, question 2.1, 2.1 and 2.2 is fine. Then will let me know when you are done, then I will see how you answered it. See you on Monday. Let me stop the video.